August 22, 1943. School of Tank Technology, Chobham, England. Dr. Robert Stevenson examines a shattered transmission gear from a captured Tiger I tank. The gear is enormous, 8 inches wide, hardened steel designed to carry 700 horsepower from the Maybach engine to the drive sprockets. But one tooth has been sheared off, not worn, not cracked, sheared, clean through hardened steel that should be indestructible. It isn't the first, it's the 7th. Every captured Tiger tells the same story. The most feared tank in the world is tearing itself apart. On paper, the Tiger was perfect. 100 millimeters of armor, an 88 millimeter gun, 700 horsepower. But of 1,300 built by mid-1943, fewer than 700 were operational. The rest sat broken, victims not of enemy fire, but of their own machinery. Stevenson, a metallurgist from Vickers Armstrong, begins his autopsy. Under the microscope, the fracture surface glitters like glass, brittle, sudden, no bending, no fatigue. He measures the hardness. 62 on the Rockwell C scale, far beyond the safe limit. Too hard to survive stress, too brittle to flex. He slices the gear open. The core is 52 HRC, the surface 64, proof of over-hardening. The outer case is twice as deep as it should be and dangerously fragile. Under magnification, the steel structure is almost pure martensite, untempered, crystalline, and brittle. Tempering, the step that gives steel toughness, was skipped or rushed. Every Tiger gear Stevenson examines tells the same story. Excessive hardness, deep case, no tempering. This isn't a single defect, it's a systemic flaw. His report is blunt. Tiger transmission gears exhibit excessive hardness and insufficient tempering. Failure under shock loads is inevitable. Translated from engineering terms, the Tiger can destroy its own transmission just by turning too hard. When Major General Percy Hobart reads the report, he sees a new kind of weapon: knowledge. If Tiger transmissions fail under stress, then the key is to create stress. Hobart circulates a secret directive to tank commanders. Force the Tigers to maneuver, flank them, make them turn, accelerate, and reverse. Every movement adds pressure. Every turn brings them closer to mechanical collapse. At first, few believe it. How can a tank be defeated by making it drive? But in Italy, autumn 1943, reports arrive. Tigers stop moving mid-battle. Not destroyed, not burning, just stopped. Post-battle inspections reveal shattered gears, locked sprockets, mechanical death. For the first time, Allied crews realize that Tiger can be broken. Not by firepower, but by physics. So why did Germany's finest engineers build a tank that couldn't survive its own power? The answer lies in the factory. By 1943, Germany's industry is collapsing under pressure. Skilled workers are gone, furnaces overloaded, bombers overhead. Production quotas take priority over quality. Heat treatment cycles that once took 16 hours are shortened to 8. Tempering, the final, crucial step, is often skipped entirely. The result is steel that looks perfect, but breaks under stress. One Czech worker later confessed, "We knew the gears were wrong. The color after quenching was off. But why should we care if German tanks broke down?" Some failures were accidents. Others, quiet acts of sabotage. Either way, the result was the same. An army crippled by its own machines. By late 1944, Tiger commanders begged for simpler tanks, Panthers, even Panzer IVs. The Tiger had become a liability, powerful but fragile. Stevenson continues his analysis through the end of the war. Every Tiger he studies tells the same story: hardness without toughness, strength without resilience. Germany, he realizes, is losing not because of courage, but because of metallurgy. After the war, Allied teams visit the factories. At ZF Friedrichshafen and Maybach, they find workers exhausted, furnaces cracked, tools worn to dust. The process meant to take 16 hours had been compressed to 8. The gears were hard, shiny, and wrong. Stevenson's findings become the foundation for post-war tank design. Tempering becomes mandatory. Quality control, absolute. He later teaches metallurgy at Imperial College London, and when asked if he felt satisfaction helping defeat the Tiger, he simply says, "Satisfaction? No. The Tigers were defeated by their own manufacturing. I just documented it." Decades later, at Bovington Museum, Tiger 131 still runs, but only gently because its original transmission remains brittle, still heat-treated wrong in 1943. The invincible tank, defeated by its own gears. Wars are not won by power alone, but by understanding how steel behaves under stress. A gear hardened to 62 Rockwell instead of 58. That small difference decided whether a Tiger moved or died in place. Stevenson proved that sometimes the decisive battle isn't fought on the front lines, but under a microscope. The Tiger's downfall wasn't lack of bravery. It was brittle steel, rushed production, and a nation that forgot. Hardness without tempering is just another word for failure.